Alright, class. How are you feeling? Every week, every day, every day. Only during OS class. Okay, insyaAllah today we are going to final part on chapter 2. Yeah, and next week we are going to start with chapter 3. Yeah? Okay, today we are going to note there's no calculation. Yeah, however, I hope that if you have any question, on how to draw Gantt chart, based on the Gantt chart, then only you may calculate. Calculate waiting time, turnaround time, response time. And remember, why do we need to know the calculation of all of those things? Waiting time, turnaround time. Because it is the basic knowledge on how operating system works. And it is how the processor, the processor works, whereby for any type of machine, especially computer, or even your handphone, or even printer, they contain processor. Processor will allow the task run smoothly. If there's no processor, how are you going to process any type of information being sent from the user to the computer? Okay, based on the processing or the processor, remember that the machines, that all of the machines, computers, laptop, desktop, allows users to do multitasking and multi-programming, and more than one task. And in order to maintain or to make sure that all the tasks, all the processors can run, even though sometimes not really smoothly, but can run completely. That's why the CPU need to schedule all of the processors based on certain type, based on certain category. For example, if the CPU scheduler uses FIFO, you can understand based on the FIFO concept, only one process can run at the same time. And if the CPU uses FIFO to schedule the processors, and if the CPU uses round robin or the hybrid, the combination of multi-queue. For example, if the CPU uses multi-queue, multi-feedback queue, how does that allow more than one process to run? That's why, and based on the scheduling, you know that by using FIFO, the waiting time for one process is how much? How long the waiting time to complete a process? And you can compare by using FIFO, round robin, priority, for example. You can compare which type of scheduling will make all the processes complete with the shortest time, and you can compare. And with that scheduling algorithm, you may apply to next courses, next semester, for example. And during programming, you may apply that concept, the basic concept on FIFO. Maybe you will learn that, or if you further your study and you major in computer system, and based on during your further study, maybe you will learn how to really understand how one OS works, and you may create a program similar to OS. Who knows? That's why for this time, at least you know the basic of how OS works and how processor in OS works. Okay, today is the thread and multi-thread. Thread and multi-thread. A thread is the smallest unit of processing that can be performed in an OS. A thread is the smallest unit of processing. A smallest unit of processing, you can relate it to a okay, all of you know about bits and bytes, 1010. Signal on off. The combination of 1010 can create a whole process. In that process, remember for any type of processor, the CPU, this CPU may create modules, may divide the processes into modular. Why? So that the process can run. For example, okay, for example, this is process 1. The CPU, your CPU may divide the processors into several modules. You can divide it into several modules. For example, P1A, P1B, P1C, P1D. Okay, from the modules, relate back. There are types of slotting into the processor, into your memory block. We have segmentation and paging. We have segmentation and paging. And also, this is non-contiguous. We have a fixed partition. Fixed partition. Ada lupa lah tu. Fixed partition is contiguous. This is non-contiguous. Okay, tengok balik. We have processors, and the processors can be divided into modular. Modular, and modular. These modules can be slot into your memory block either by using non-contiguous or contiguous. Contiguous way to slot into where? Memory block. What happened? What happened? When the segmentation paging and segmentation paging fixed partition relate back may use scheduling, several types of scheduling algorithm. This one is FIFO, apa lagi, FJF, SRTF, lagi round robin, priority, multi-queue, semua tu multi-feedback queue, multi-queue. This is the basic. Inside this, when all of the processors divided into modules, dalam ini we have threading. Thread, multi-thread. Small amounts of things in OS we call that thread. Macam benang. For example, in a one piece of cloth, you have several threads inside the main cloth, yeah. Inside your main cloth, there you have several threads, the smallest amount is, yeah. Okay, the smallest unit of processing that can be performed in an OS, yeah. In most modern OS, a thread exists within a process. That is, a single process may contain multiple threads. Yeah, similar to this, one main process, the CPU may divide them into modules of process. And the modules of process, inside the modules of process, you have threads and multi-threads. And threads and multi-threads, whereby logically the threads sebenarnya are divided into the memory block sebenarnya, logically. Yeah? Why? Because the memory block does not, our memory block only recognize 10, 10, 10. And the memory block cannot really understand. Okay, assignment 1 DOC pun masuk dalam memory block. It doesn't understand that. Only recognize 10, 10. And your assignment .doc, okay, in digital number it contains 10, 10. And your task, your task, for example this one, assignment .doc, assignment .doc contains, instead of we call 10, 10, we call it, inside it, contains threads and multi-threads. Threads and multi-threads. And the threads are logically divided into or slot into your memory block, either by using non-contiguous or contiguous partition. And the non-contiguous or contiguous partition are scheduled by using either DIP2A, SHAZARIN, depends on the CPU scheduler. That is the basic, the concept. How your processor works sebenarnya inside your CPU. Multi-threaded application has multiple threads. Multi-threaded application has multiple threads. In a single process, each having their own program counter, stack and set of registers. However, share common code, data and certain structures such as open files. For applications that contain multi-thread, have their own program counter, stack and set of registers. These are the address. However, share certain code. For example, how to open the file. Okay, this is a single threaded process. Thread, and you have for this thread, register, stack, code, data, files. This structure inside for a thread, and this one is a process. Process. For multi-threaded process, each thread has their own code, have their own counter, stack and set of register, have their own counter, stack and register. However, share certain structures. Why? Because when they share how to open the file, all of the threads in the process may open. When the CPU asks to open the file, for this process, for multi-threaded process, all the threads will open. Okay, for example, in a word processor, a background thread may check spelling and grammar, while a foreground thread processes using input. A thread loads images from a hard drive, automatic backup for a file being edited. Okay, this one, for a word processor. This is for example of multi-threading, word processor. A background thread may check spelling and grammar. A background thread ni maksudnya processors, processors di belakang automatically will check spelling and grammar while you type your assignment. When you type your keyboard keystroke, so for example you type something like assignment 1, background, CPU is when you typing, background thread will check the spelling and grammar. This part understand tak? One thread check spelling and grammar, another thread process your input. Okay, faham tak part ni? Another thread will check images from hard drive. Maybe you want to load images, or in the background you are installing something, maybe. And the fourth may do backup. Okay, this is for one process. There are several threads running. For one process, there are several threads are running. Threads. Okay, another example is a web server. Okay, for example, allows multiple requests to be run to satisfy simultaneously without having to request sequentially. Okay, for example, for a web server, more than one PC are running and they request for the same data. Request for the same data. How the request can be the web server can send the request to all the distributed computers. The web server can send all the requests to all the computers without the computer need to wait for a long time. That is multi-threading concept. Separate processes for every incoming request. Okay, benefits of multi-threading. Baca lah baca sini Lambat dulu baca sekejap. Okay, kalau banyak word sini, what I want you to highlight is the keyword. Utilize the processing power of a computer processor. Of course if you have multi-threading, the smallest threads ini can be run at the same time. Dalam proses P1A divided into threads, and the threads can run on their own way. Jadi bila for P1A, the thread can slot into any types of memory block to run based on the request. Then P1A can terminate or complete faster lah. Instead of lump sum of one module of P1A needs to wait. P1B needs to wait. Maybe this one you have 1 meg. You can divide it into 100 KB and the threads may 2 KB. When one large file divide into smaller and the smaller part divide into the smaller one, even smaller, then the small file can run faster kan? Kalau the concept is like that lah. That's why the developer think about what is the new way to increase the OS operation. Okay, if a thread gets a lot of fetch methods, another thread can continue taking advantage of the unused computer resources. Okay, for example, kalau one thread kat sini, ni cache memory kan. Another thread kan run lah and overtake the unused resources. Jadi, for one module, all of the whatever it is, by the end, all of the processes, all of the threads can run lah, can execute, can be executed. Okay, if a thread cannot use all the computer resources, running another thread can avoid leaving this idle. Okay, for example, kalau this P1A thread ni cannot fulfill or optimize the computer resources, resources macam primary or secondary memory, another thread kat sini boleh use lah, can fit or optimize, support each other. P1A will be supported by P1B. Okay, the benefits are simplify coding of remote procedure calls and computation, simultaneous access to multiple applications, and reduce number of required servers. Why? Because dispatch multiple threads, service threads, the number of the servers to start for your own application is reduced. Okay, we have learned how processors divided into modules and how the modules divided inside the modules to contain threads. And the threads are being slot or execute by the CPU into the memory. Memory block. And from the memory block, dia pergi lah mana-mana dia nak. Maybe printer, maybe monitor, maybe save into hard disk. Maybe you want to create your program based on the request. And imagine that more than a lot of process run at the same time. We have P1, we have P2, we have P3, and the P2 ada lagi modul. Kemudian P3 pun ada lagi. Kemudian dalam ni ada lagi threads ni. Semua ni nak masuk dalam memory block. Sometimes your computer will freeze. Kan? Banyak sangat traffic jam. Kan? Okay. That's why we have the term of deadlock. Macam highway sempit kan? Lepas tu sempit, lepas tu by the end of the tunnel baru disperse lah. The data or the processes are being dispersed. We have deadlock situation. Each process needing what another process has. This results from sharing resources such as memory devices and links. Under a normal operation, a resource allocation proceeds request a resource, suspend until available is necessary. For example, request a resource for P1 have slotted into have used all the memory blocks. P2 wants to go also, however needs to wait for a while. Use the resource, and what happens after the request of a resource? P1 request, P1 is using, P2 request. After P1 is released, then only P2 can use the resource. Request, use and release. Slow lah. Request for to use in memory block, use the resource and release the resource. Use the resource ni maksudnya memory block lah. Memory, primary memory, power supply. Release the memory after you have used, complete and release. Okay, this is what I mean by traffic jam or deadlock, for computer. Traffic only occur in one direction. Macam ni lah. Semua masuk. Kemudian keluar. Dia tak akan masuk pergi balik tak ada. Dia akan masuk, keluar. Dia ikut cycle lah. Even in the cycle we have new, ready, execute, and if the execute cannot, if the execute are being preempt, it will be blocked. In waiting state kemudian after completed, then it is terminated. Cycle dia macam tu. Dia takkan ada, sana sini tak ada. Nanti kalau macam itu akan berserabut lah, kan? Akan berserabut your CPU. Okay, if section of a bridge can be viewed as a resource, macam ni, input, output. And if a deadlock occurs, it can be resolved in one car backup. That's why the concept of preempt. And that's why the CPU has the concept of preempt. Kalau deadlock macam ni, this is deadlock. The CPU needs to schedule which car should reverse, either A or B. Depends on the priority, for example, or depends on the shortest stop first. Delete back. Okay, several cars may have to back up if a deadlock occurs. Kalau dia dah jam sangat seperti tadi ni, several cars need to back up. If there's no process being blocked or suspended, nothing will run. So your computer you need to control alternate delay. Itu je lah caranya. To prevent that thing, maknanya if every time free saja control alternate delay, awak punya file semua tu dia hilang lah. Penting lah jadi kan. And starvation is possible. Starvation ni maksudnya langsung kosong lah. Bila semua backup mungkin kosong, then the CPU akan slot balik new processor to occupy the free space. Okay, characters in deadlock. All of these four must happen simultaneously before a deadlock to occur. Okay, benda ni, all of these four situation must happen simultaneously before your CPU runs deadlock procedure. Before your CPU runs deadlock procedure. For example, the first one is mutual exclusion. Only one process at a time can use a resource. Number 2, hold and wait. A process holding at least one resource is waiting to acquire, is waiting for additional resources held by a process. Hold and wait. A process holding at least one resource is waiting for another resources. No preemption. A resource can be released only voluntarily by the process holding it. There's no preemption. And the singular wait. There exists a set of processors operating processors such as P0 is waiting for resource held by P1 and P1 is waiting for a resource held by P2. Maksudnya P0 waiting for P1, however P1 is waiting for P2 and P2 waiting for P3 and so on. Okay, when mutual exclusion happens, hold and wait happens, no preemption happens, and singular wait happens, then only your PC or your CPU will run deadlock. Will run deadlock to prevent the deadlock. This is when all of the processes happen in the same time, then only it is called deadlock. Then only this the CPU is called deadlock. Deadlock is happening. How after when deadlock deadlock is to ensure that the system will never enter a deadlock state. To prevent this from happening, to prevent deadlock from happening, the CPU needs to ensure that the system will never enter a deadlock state. It's to prevent lah. You don't want deadlock to happen. So the system needs to make ensure lah. Yeah. How are you going to make sure that the system can ensure? By the programming. So sebenarnya, when the developer develops the OS, allow the system to enter a deadlock state and recover. Dia akan ada masuk deadlock and buatlah recovery state. Yeah. Or just ignore the problem and pretend the deadlock never occurs in the system. Boleh juga macam tu. Ya. Untuk unit selalu macam tu. Biar je dia deadlock. Ini adalah sumbat tu. Tapi lastly dia akan jalan juga lah, lambat lah. And this is how methods to handling deadlock, yeah, for your OS. Okay, macam ni lah character dia, solution dia. How to the solution, mutual exclusion. You can hold and wait, must guarantee that whenever a process requires a resource, it does not hold any other resources. Nah, ni terbalik kat sini ya. Terbalik kat sini ya. Ini character happen kalau ada mutual exclusion, hold and wait, no preemption, circular wait. Ya. To solve that, in for mutual exclusion, not required for shareable resources, must hold for non-shareable resources. If hold and wait happen, must guarantee that whenever a process requires a resource, it does not hold any other resources. Kalau no preemption, if a process is holding some resources request another resource, then the resources being held are released. Yeah? Kalau for example one process is holding just occupy the memory block, automatically the CPU needs to release that process. Yeah? So that another new process can slot into that space. Yeah? Or if circular wait impose a total ordering of all resources types and require that each process requires resources in increasing order of enumeration. Yeah? Allows processes to hold, release. Yeah? Send, use and release. Make sure that is happening. Okay, strategy. Prevention, avoidance, allow it to happen. And detect. Detect knows the deadlock has occurred and recover lah. If Windows knows that a deadlock is happening. Yeah? It needs to detect, and after detect, it should recover. If we have prior knowledge on how resources will be requested, yeah, possible way to determine, yeah, we are in safe state, deadlock, no forward progress can be made. Hang je lah your PC. Unsafe state, a state that may allow deadlock. Yeah, for example, running, downloading YouTube, kemudian rendering your movie, lot of things are happening using occupy your memory. Awak need to prevent that from happening lah. Yeah? Similar to your handphone, yeah? If you have running application at the back, clear them. Yeah? And also safe state. A state is safe if a sequence of processes exists. Okay, enough resources for the first to finish, then only the second will use that resource. Okay, all deadlocks are unsafe, but all unsafe are not deadlock. Yeah? Deadlock ni memang unsafe lah. You want to prevent that from happening. However, yang tak safe tu tak semestinya deadlock. Habis. Okay. Okay, saya sedang waktu dah sebenarnya. Yes, tadi mak. Yes. Sejam je. Okay, to prevent your brain from having that lock, saya bagi awak masa. Flip balik. Cover. To prevent your brain from having that lock. A lot of processes are being processed in your brain, kan? By your brain. Saya bagi you have 15 minutes untuk read balik. Okay, read balik. Benda deadlock ni, cerai semua saya balik. Buat kita semua. Okay, if you have any question, boleh datang depan ya. Saya tak pergi belakang. Semua datang depan. Nama Afif.
Saya.
Husna.
Saya bukan.
Mana Husna Izaki? Nur Al-Zalifa. Mana Nur Al-Zalifa? Izzuan. Amirul Azhar. Nur Nadia. Arifah. Shalini. Nur Aida. Nur Akif. Nur Hanani. Ashrafullah. Michelle. Muhammad Muizuddin. Nur Syafiqa. Nurul Adila. Azmira. Afiq. Devian. Nur Syaraf. Nur Syafara. Muhammad Hafiz, Zulkifli, Ahmad Lukman, Robert, Nur Zafira, Putri, Nandini, Muhammad Fikri, Muhammad Najib, Nurul Syifa, Muhammad Zuhrani, Siti Aisyah, Nur Fatih, Muhammad Azrai, Evandran, Iranda, Sivia, Tanya Soran, Muhammad Idin, Muhammad Idin, Muhammad Idin Ehsan. Nama ada Muhammad Idin tak ada?
Ada kelas lain.
Kelas lain.
Lagi kuat gelap.
Question ni nak tanya saya ni. Ada nak tanya soalan? If you take out a piece of paper, okay, write your name, your message number and your class. Yeah? Okay, no talking, yeah? No talking. Only one question je. Okay, satu soalan je. Okay, dah. No talking. Okay, 10 minutes. Ya? Macam ni ya. Okay, no talking please. 10 minutes. No talking. write something ya, sedang dia kosong. Dia kosong. Mesti sesuatu. Nanti saya fit yang on apa in the blank tu. Another 5 minutes ya. Another 5 minutes. Time's up. Minit lagi tak boleh, okay? Ini pun sepatutnya 3 minit je. Ya? Okay, time's up. Please stop writing. Ya, stop writing. Just submit friends, campur tak apa. Ya, do DIP2A, do DIP2B, campur. Okay? Okay, stop writing please. Yes, stop writing. Jangan dulu lagi, saya kira kan? Kira kan? Dah. Okay, hantar depan please.
Tak tahu dia mana.
Cukup kita email ya. Okay, semua dah hantar depan. Okay, for next week, Puan Haslinda will take over this class ya. Okay, new topic. So, if you have movie ya, if you have any question, topic 1 to topic 2, okay, ask me ya dalam in my room ya. Or if you want to ask Puan Haslinda, okay, if you want, okay, for topic 3 and topic 4, yeah, starting from next week, Puan Haslinda will take over the class. Okay, only for lab, I'm going to see the DIP2A. For the DIP2B, if you have any questions, yeah, you may ask me anytime, yeah, when I am free, yeah. If not, you may, kalau tak apa, you may set an appointment, yeah. DIP2B, so all the best for the DIP2B and congratulations lah, dah habis sampai 20. Yeah. Okay, thank you.
Apa tahu apa? Banyak.
Itu yang rawat dia dulu rawat tapi dia check
Maknanya dia tak interact dekat dulu ni.
Dia hanya datang dalam medicine saja.
Oh, dia bukan macam kalau 20 atau dia panggil 20 dari 20 sampai 20 lagi 20 lagi video. Itu lagi video.
Dia continue.
Kalau kenapa sudah tu? Selain tu mana?
Betul lah. Dia akan basic dia pergi sampai ini dari motornya. Kan ada. Jadi dia akan basic 15. Lepas tu selepas lepas mengaji baru naik boleh.
Dia jalan 15 lepas tu dia
Dia kena buat jadi yang dulu
Ha,
kan.
15.
Kalau dia rasa lah kan.
Balance kira tu. Kosong tak kosong. Mana konsep?
yang apa dekat waiting tu saja. Depan waiting tak ada.
Dia tak akan ambil buat recital tu adalah first initiate je. First time je dia ada.
Dia masuk.
Tak apa kau. Kalau dia Robi dia kan banyak. So nanti
Every sudah every.
Macam tengok tu ada tulis.
Ada first execute je. First execute. Kita tak ada kira yang lepas tu kita tak kira.
Yang turnaround time tu end time tak?
End time, questionnya boleh tapi kalau ada projek, boleh lah pergi tolak dia. Boleh lah kalau
Dia dah panjang. Sebelah seminar tu yang dekat nama projek.
oh. Thank you, Wan.
Kami dekat ni dulu. Kan. Dekat ni dulu. Okey. Saya nak check lah awak cakap apa ni. Oh, ikut saya nampak ni betul lah tadi. Dia ada banyak paper. Jadi campur mesti 100 kan? 100 kalau sebab apa dia bermula ni? Bukan dia ni je. Tak lari kan? Sebab dia kan 40. Jadi dia tak balik pada 1. Jadi dia bermula tak selama. Jadi dia jadi untuk bermula dengan macam tu lah. Kita tunggu tolak nanti dia berjalan. Sebab dia belum buat ni. Dia tak rani lah. Konsep dia tak rani. Dia tak ada pun. Bukan video dia. Waiting time. Kalau awak tengok waiting time, masa menunggu. Masa menunggu. Ini dia tak tunggu. Jadi dia tiba ni. Dia menunggu tak selama. Tunggu lah. Dia menunggu start daripada slide. Ini pasalnya dia campur. Okey. Dia running balik. Pada satu. Dia kena menunggu sejak sejak apa? Sebab dia dah ini dah fitting. Masa kerja awak dah lama ke bank ni, masa tu 40. Masa 40 saat ni, orang lain kosong, awak kena pergi tersebut. Aku pun tak selama tu. Lepas tu dia panggil balik awak pada masa ke-100. Sebenarnya 100 talak 20. Dia terbuat talak 20. Oh, sebab salah. Prepare dulu, faham boleh? Salah. Cuba sana. Boleh tahu waiting time.
Dapatnya memang satu sekolah apa tu? Dengan Cina tu salah.
Tahu lah di antara telur masuk P3, P1 ni semua tak ada, dia menunggu. Jadi dia tengah tu tak akan berkata. That's betul. Tapi nak
Kalau kita kontak sama lah, tapi beza nama satu ni pushing out tu macam kongsi lah, selesai satu bersama kali ni dia akan di kongsi.
So, kalau first-come first-serve, anda kata bukan lagi besar berbanding pada proses sama ini.
Dan lebih besar dari kerja.
Tapi proses satu kan, rasa dia sama. So, kita akan buat yang pada dua lah.
Dia next ni first-come dia.
Kalau priority dia sama,
Priority sama.
dua. Lepas tu kita tengok first-come tu, kita tengok first-come first-serve.
Dia tak akan tengok pesan. Dia tengok pesan. Itu sebab dia kena check. Dia guna, kalau kali ni dia akan tengok priority. Priority dia tengok kita dah check lah sampai sampai dulu.
Kalau sampai sebab ini kan ni kan, dah tahu. Tapi macam tu dia tadi yang
tidur.
lepas tu kan pada anda ini yang tu tadi kan.
Okey, dia jawapannya buat proses alterasi model. Okey. Jadi apa nombor ni?
Jadi kita ni sudah walaupun bukan dia dia bukan yang besar maksudnya dia memang konflikkan diri dulu ke ataupun dia nak sama
Dia tak akan interrupted. Dia tak akan, dia tak akan interrupted sebab tak kacau. Dia tak tengok shorter, kita tak tengok. Tengok hanya kot priority lah. Priority,
kemudian settle
dia sebab dia tak check, dia tak ada SRPF. Kalau SRPF, dia memang nak balance yang paling kecil. Kalau konsep ni, kalau SRPF, dia ada yang paling ni mesti pun mungkin ni sama tapi dia juga SRPF. Jadi dia ambil
kalau SRPF kan ikut shorter sini tak memang kalau berdasarkan dalam program D2 dekat 2 dengan 5 ini ada pesan yang sama kalau shorter ikut saya mau kalau kita buat dalam tadi
itu saya kata kalau orang nak tu check konten orang nak begini lagi sana semua dia dah dua dia dah nak semua seperti tidak ada sampai pada kontrol pada masa kita sampai tapi check dia punya jadi balance kan compare balance itu dengan E1 balance itu dengan E1 jadi dua ni satu jadi kita laksanakan dan apa yang tinggal P2 dengan P4 dan juga yang ni lah P1
tapi P2 lagi dia buat bukan kita buat penyelesaian kan sebab besar dia sedia walaupun dia sampai lambat tapi besar lagi sikit dia bagi
daripada balance
okey
tahu kan? Tidak, sana di sekolah itu ada kendaraan ini. Itu dulu boleh. Itu SHAZARIN detensi. Orang yang buat regulan kenderaan saya dah letak atas meja. Jadi hari sebelah tu dia ada kenderaan lagi tak? Kalau saya telefon sana, boleh tahu ke ataupun pergi letakkan juga? Apa yang saya call balik? Okey. Okey. Boleh saya hantar kat saya? Kenderaan tak tahu. Jadi tapi kalau hantar je lah, hantar je yang detail tu nanti akak tu malam untuk tanya. Kalau Ali sama semua tukar nombor lah, tukar nombor ini sama dia juga tak tahu nombor seperti ini nanti akak tu ni lah orang 3 kan bulan kan. Tengoklah kenderaan tu tak ada, tersulang boleh nak pergi sendiri tak tahu lah. Okey. Alright. Ni sekejap, ada air kawan your friend si tinggal tu. Kalau lain, ada tak DFP? Ada. Sekarang kan, saya kunci. Mana pergi? Buka. Ayo. Nanti kan marah ada kamera. Nanti kena sama nanti. Nanti kan dah harga. Ya, tadi buat dia.